Solve the triangle. We assume that this follows the convention labeling with the vertices of the triangle A, B, C. The side that is opposite to the angle A is the lowercase a. The side that is opposite to the angle B is the lowercase b. And the side that is opposite to the angle C is the lowercase c. We were given that the lowercase a is 18, the lowercase b is 20, and the angle A has a measure of 63 degrees. This is a side angle size scenarios, so we will use the law of cosines. The side that is opposite to the given angle is lowercase a. The law of cosines states that this is a squared equals b squared plus c squared minus 2bc times cosine of a. The lowercase a is given 18. The lowercase b is given 20. We do not have c, so we would rewrite the equation. Minus 2, b is 20, c is still not known, times cosine of 63 degrees. The goal is to find the unknown lowercase c in this case, so we would simplify this. 18 squared is 324. 20 squared is 400. 20 times 20 plus c squared minus 2 times 20 times cosine of 63 degrees. But don't forget that there is a factor of the lowercase c there. This is 324 equals 400 plus c squared minus, evaluate 2 times 20 times cosine of 63 degrees in a calculator using degrees mode. We get 18.1596 and we bring down c. We then zero this out by bringing 324 to the right hand side. We obtain 0 equals 76 plus c squared minus 18.1596c. The goal is to find c. This is the quadratic equation c squared minus 18.1596c plus 76 equals 0. To solve this quadratic equation, we will rewrite this in terms of x, where x squared minus 18.1596x plus 76 equals 0. Because we are accustomed to solving a quadratic equation with x. The quadratic equation states that the solution x equals negative b. b is negative 18.1596 plus or minus the square root of the discriminant. The discriminant is negative b, negative 18.1596 squared minus 4 times a times c over 2a. A and b and c in the quadratic formula are the coefficient of the quadratic equation. C in the quadratic formula is not the length c we're looking for. We simplify this to get x equals positive 18.1596 plus or minus the square root of this expression using a calculator is 25.7711, still under the square root, and then over 2. There are two x values here. x1 is 18.1596 plus the square root of 25.7711 over 2, and this is 11.62. x2 is 18.1596 minus the square root of 25.7711 over 2, and this is 6.54. What this means is that we found 2c. C1 is 11.62 and C2 is 6.54. The consequence is that we have two triangles because we found two possible values of C. We then summarize the result or update what we have so far. So far, we were given that the side A has a length of 18 with the corresponding opposite angle. A has a measure of 63 degrees. We were given the lowercase b, 20. We found C, 11.62. But there is another scenario as well, where we found C equals 6.54. So we now have two triangles. For the first triangle, to find the angle that is opposite to the length C, we use the law of cosines, which states that little c squared equals a squared plus b squared minus 2 times ab times cosine of c, where uppercase c is unknown. The lowercase c, we found it was 11.62. The lowercase a is given 18. The lowercase b is given 20. Minus 2, a is 18, b is 20, then multiply cosine of c. We then simplify this. 11.62 squared minus 18 squared minus 20 squared equals negative 2 times 18 times 20 cosine of c, where we isolate the terms with c. The left-hand side is negative 588.9756, and the right-hand side is negative 720 cosine of c. We then isolate cosine of c to get negative 588.9756 divided by negative 720. A negative divided by a negative is positive. We then use cosine inverse to find c. Cosine inverse of 588.9756 divided by 720. Using degrees mode, we get 35.1149, or approximately 35 degrees. With this, we see that for the first triangle, the angle that is opposite to side C, that has the length of 11.62, that angle has a measure of 35 degrees. Once we get two angles in a triangle, we can find the remaining or the third angle by taking 180 degrees minus each of the angle that we found or given. 180 minus 63 minus 35 is 82. And so the angle B has a measure of 82 degrees. But that is only the first triangle. To find the missing information of the second triangle, we simply repeat the procedure. But this time, the lowercase c is 6.54. So we take 6.54 squared equals 18 squared plus 20 squared minus 2 times 18 times 20 times cosine of c, and then we isolate cosine of c, very similar to what we just did on the left hand side. We take 6.54 squared it minus 18 squared minus 20 squared equals negative 2 times 18 times 20 times cosine of c. The left-hand side is negative 681.2284, and the right-hand side is still negative 720 times cosine of c. 720 cosine of c equals 681.2284. We rounded to 4 decimal places in the intermediate step just to be safe. We can just get away with it by using less number of decimal places. Isolate cosine of c. Cosine of c is 681.2284 divided by 720. We then use cosine inverse to find c. Cosine inverse of 681.2284 divided by 720 is approximately 18.8888, or simply 19 degrees. And so for the second triangle, the angle C is 19 degrees, correspond to the length C equals 6.54. Once we have the angle C and A, we can find the angle B. The angle B is 180 degrees minus 63 degrees minus 19 degrees this time. Again, this is another triangle. This would give us 98 degrees. And so, to summarize the result, again, we found two triangles. For the first triangle 1, the lowercase a is 18, the uppercase a is 63 degrees. The lowercase b is 20, the uppercase b is 82 degrees. The lowercase c is 11.62, the uppercase c is 35 degrees. If we were round the result, the final answer to a whole number, then 11.62 can be rounded to 12, but only rounded in the end. Don't round it in the intermediate step. For the second triangle, the lowercase a is 18, the uppercase a is 63 degrees. There's nothing we can do about these because these are given. The lowercase b is given 20. The uppercase b, we found it. It is 98 degrees. The lowercase c, we found it. It is 6.54. And the uppercase c is 19 degrees. And again, if we are to round the final answer to the nearest whole number, then 6.54 can be rounded to 7. For both of these two triangles, we might want to double check that this is reasonable. For the first triangle, the largest angle has a measure of 82 degrees, which corresponds to the longest opposite side. The smallest angle is 35 degrees, which corresponds to the shortest side. For the second triangle, the largest angle has a measure of 98 degrees, which corresponds to the longest side. And the smallest angle has a measure of 19 degrees, which corresponds to the opposite shortest side, which is 7.